Welcome back, guys. In the previous lecture, we started working with functions and compiled the main function, right? That is the main entry point. And today we'll talk about external functions. And let's start right away, going down to our gen function, right, which currently handles just the number 42. Exactly the same, we will hardcode today just the string hello world, right, until we have parser, start accepting actual expressions. For now, we just need to understand how the string looks like. Now, all the literal strings, that is the strings containing only characters, are considered global strings. And for this, the builder has the method which is called create global string pointer, where we pass specific string. Okay, sounds good. That's pretty much it. There's no any magic in the global strings, and this should just work. Let's try and execute. And there we go, we got our string. Let's take a look. Now, first of all, we see that the string is saved into a variable, %0. Remember, as we said, ampersand prefix is used for global symbols, right? For example, the function main has the ampersand. And also this variable 0 is also global. Also, LLVM, similar to C++ or assembly, treats strings as just arrays of characters, right? Byte arrays. In this case, we see 15 bytes are allocated, specifically for the string itself, plus the new line characters. Also, we see the notion that the strings are constant, and from the memory perspective, they're byte aligned, that is aligned 1. And if we take a look at the return value now, it suddenly becomes 0. And this happens because we used cast to i32, right, the return value of main function. Now this worked with a simple number 42. In fact, for our test, we'll need to see actual results, that is the actual string printed. So in today's lecture, we will introduce the function printf. In fact, this will be operator, which under the hood is implemented as the external function, right? The function which is defined somewhere in the standard C++ library, so we'll be able to call them. But first of all, let's get rid of casting to i32 and unconditionally return 0, right, as the success code. Let's test it. It looks great. And start introducing the printf function. In the previous lecture, we said that we distinguish functions on declarations and definitions. And a function declaration is exactly the information about its prototype, that is about its header. That is, we have just the function name, its type, but not the actual implementation body. Meaning this function came from somewhere else. It might be a different module, might be a standard library. But for LLVM program, we should be able to define such function, right, to declare. And for this, let's introduce the helper method called setUpExtern functions. Now, to declare a function, such as printf, we use the method on the module called getOrInsert function. Exactly the same passing the function name and the function type, right? Similar as we had for our compilation function, this will be handled automatically. So we declare a function called printf, and now needs to specify its type. To create the type, we use exactly the same method, function type get. As we said, have multiple constructors. In this case, we need to pass also the parameters. First of all, we specify the return type, which is int, that is i32. And from the standard library, printf accepts the format string, which is the null-terminated character pointer string. And the char class from C++ is just the alias for the byte. And the way we do this in LLVM is exactly defining an extra type. Let's call it byte pointer type, which is calling the getInt8 type on the builder, and also extra getPointer2, right? Without getPointer2, we just get i8, and we need i8 star, that is the pointer to a byte. Okay, perfect. So the format string goes as the first argument. And as you can see, printf function can accept multiple arguments. That is, this is exactly the var arg. So we specify that yes, printf actually has the var arg, passing the last argument as true. So that should be it. Let's get back to the constructor of our compiler. And after we have initialized the modules, we set up the external functions. Okay, sounds good. So this should declare the function. Let's test it right away. Execute. And as you can see, we have the printf function. Take a look. The keyword is not defined but declare, which exactly means we don't have the body, but we know the signature of this function, right? The prototype. So let's get back to our compile loop. Let's save the string into a variable. And let's implement the call to the function printf, right, to the external function printf. Now, to implement function calls, first of all, we need to get the function. Exactly the same we call the get function on the module, passing the name. Then we have to set up all the arguments. In this case, we have the string format, which may follow with multiple values. And today let's support only just the plain string, so the only argument, the string itself. And then it's plain simple. There's API method on the builder, create call, passing the function, and passing the arguments. And that should be pretty much it. Let's try it. Execute. And let's take a look at the call. Here we see the call instruction itself, right? The return type, the parameter types, right? The pointer to a string and multiple args. Then we see the function itself, and then some cryptic instruction called getElementPointer. And we will consider this instruction in detail in the later lectures. For now, take a look. We just passed the global string, that is the %0, which is also the pointer to the character arrays. But again, we'll get to this cryptic instruction getElementPointer in the next lectures. For now, we just need to know that we passed the string. And we see the actual result, that is the string is printed. Okay, so that's it for today. We got familiar with the global variables, right? Again, we see the prefix %. We got familiar with the raw strings, and we also got familiar with function calls. We also got familiar with the concept of external functions, that is function declarations. And also the good question, why does it work, right? Where this function printf comes from. If you remember from the LLVM config, which we pass in our compilation, we pass the flags that we need to include standard libraries and core libraries. And printf is part of those, so we can normally call it from our programs. Okay, in the next lecture, we'll start accepting actual expressions, and we'll talk about parsing. That's it for today. Thanks and see you in the class.